So again, we want to welcome everybody to tonight's webinar. With me, we have three of our heavy hitters tonight. We have Rodney Chai, one of our meteorologists, and two of our lead meteorologists, Hayden Frank and Frank Nocera, to go through this review of the October 30th early season snows. So Rodney, Hayden, and Frank, thank you as always for helping out put this presentation together and for each of you presenting tonight. Really appreciate your help. So with that, we'll get started. This is the first snowfall of our 2019, no, it's not. It's 2020 to 2021 winter season. Got a wrong label there in southern New England. And that was a view outside of our office as the snowflakes were coming down on October 30th. So I guess I'll have to fix that, guys. So just first, I guess I'll go through the overview here. We had tropical moisture from Tropical Storm Zeta that combined with very cold air and strong lift, which led to several hours of moderate snowfall. So we'll go through some of that through the model guidance. The liquid precipitation, as you'll see, was well forecast, but the models didn't pick up on the higher snow to liquid ratio, which we called SLR. So it's always challenging to forecast SLR in a scenario where rain changes to snow and also in early season and late season events. So think October, November, and then into March and April. That's always a challenge. There were winter weather advisories issued despite the expectation that snowfall in most locations, 1 to 3 inches, would fall below criteria. But our forecasters felt it was important to hit the messaging harder given it was the season's first snowfall and also coincided with the morning rush hour. Despite a fair number of people staying at home and working from home because of COVID, there's still a fair number of people commuting to and from work each day. So they felt it was important to hit that a little bit harder. And the high SLRs and the cold low-level temperatures ensured the snow was dry and powdery, which ended up minimizing power outages, except in locations near the coastal front, which we'll get into a little bit, where it was wet and heavy and there were some power outages. So for the first part, we'll go over the messaging and the forecast.
All right, great. Thank you, Joe. This was obviously when you're dealing with a potential snow event at the end of October, your confidence, especially several days out, is going to be relatively low given your temperature profiles are really usually on the cusp between rain and snow. But if you remember, the snow event was late Thursday night and especially during the day Friday, and this was the first message we sent on Monday, October 26th, indicating the potential for minor snow accumulations across interior southern New England. Now, obviously, it did reach further south and east, but from a first starting point, kind of not a bad idea, as the models really handled the overall theme of this quite well. It's just kind of pinning down how far southeast the snow will get. And accumulating snow anywhere across southern New England is relatively rare in October. It does happen, but especially along the Boston to Providence corridor, it's extremely rare. And we'll talk about that a bit more as we get later into the presentation. So this was our first official snowfall forecast that was issued Tuesday afternoon. So we're about 72 hours out from the forecast. And what you'll notice is forecasters hit the interior fairly hard, considering, we're still 3 days out in late October. Generally, 1 to 4 inches for a 72-hour forecast. That's going out pretty good for something that's in late October before Halloween. But you'll notice, obviously, not much, basically no snow was forecast on the Boston to Providence corridor. And again, the thermal profiles, which dictate whether we're going to get rain or snow all the way up through the atmosphere, are very sensitive. So a couple degrees cooler can make all the difference, and that's what exactly happened. So as we move along here, one of the things we started doing several years ago was to kind of give a high-end threshold and a lower-end threshold, giving somewhat of a range of possibilities. Now, again, this isn't meant to be exact, but you'll see this 72-hour forecast on the higher end did give the possibility for a couple inches of snow right along the coast, which would be extremely unusual. And obviously it did happen. Now, amounts were still underdone, but it kind of gave an idea of if the models trended a bit colder, what could happen. And then this is another useful tool. I know emergency managers really like to look at this, confidence level. What is your probability confidence level on getting 1 inch or more of snow, 4 inches or more of snow? This can be really useful for those folks that have to make the decisions. And what you'll see is even though we weren't forecasting accumulating snow at the time as the most likely scenario in the Boston to Providence corridor, you'll notice about a 22 to 28% chance of receiving 1 inch or more of snow. So what that says is, even though that's not the most likely outcome, there's a 1 in 4 shot that we are going to be dealing with accumulating snow right on the I-95 corridor. And then also look, as we get into the Worcester Hills, the Berkshires, almost 60-70% chances of receiving greater than an inch of snowfall for a 72-hour forecast. So that's kind of giving some pretty good confidence in a rare late October snowstorm. And this was the actual total precipitation forecast from this event. Remember, we were actually dealing with a tropical storm passing to our south. So moisture here wasn't going to be a question. We knew, we were going to be dealing with, a significant precipitation event. What the uncertainty was how quickly the cold air was going to come down from the north. And one thing to keep in mind when you're dealing with whether it be a tropical storm or a, strong low pressure system, the atmosphere remains the same in such that when we're dealing with low pressure, we're dealing with counterclockwise winds. So if that low passes to your south, whether it is a tropical storm or, a typical storm we see in the wintertime, you're going to be on the cold portion of that storm. Just in this case, we had a very unusual amount of cold air for late October. Obviously, that's gone completely away in the last week. It's hard to believe this even happened. So this was a look at the forecast track of Tropical Storm Zeta. It initially was a hurricane, kind of came up through the deep south and then passed off the Delmarva Peninsula at 7 p.m. Thursday evening and was, headed east. And again, we were going to be on the northern side of that storm, which means the cold side of the system. And as things kind of consolidated and we got closer to the event, we definitely recognized the trend towards a colder solution. And you'll see this was the forecast issued Thursday afternoon. So we're about, say 12 to 24 hours out from the event. And generally a 1 to 3 inch snowstorm is being forecasted along and northwest of the Boston to Providence corridor. You'll see the higher amounts indicated in central Massachusetts and in the Berkshires. That's obviously given that they're the high terrain. Again, this was tricky because temperatures hadn't even been below freezing yet in a lot of these areas. So it was difficult to say how much was going to accumulate down along the I-95 corridor, and that was the forecast dilemma. And as we go forward here, this would be a potential high-end snowfall amounts. And what you'll see here is a kind of a step up from what we had a few days ago. We're indicating almost a half a foot of snow in a high-end scenario into the Worcester Hills, into the Berks. And now you'll see 3 inches all the way down to almost the I-95 corridor. So while we didn't recognize the amount of cold air, how quickly it was going to come down, we were starting to get on the path that the trend was colder and snowier, even all the way to the coast. And this is what eventually prompted that winter weather advisory to be issued for much of the region. And now as we look at the probability of 1 inch or more of snow, notice across central Massachusetts, it's greater than 75%. So that's giving emergency managers, road crews, fairly high confidence that we are going to see accumulating snow. And even onto the Boston to Providence corridor, we're seeing nearly 50%. So that's good. Notice how quickly the snow cuts off There was more snow than we indicated, obviously down into Plymouth and Bristol counties, but not much on the Cape at all, other than some, wet snowflakes. And the reason for that was the wind was from the north. Well, that brings cold air down for most of the region. Remember, it's coming over the ocean, which is still, in late October in the 50s. So it's really tough to get accumulating snow anywhere, but especially on the Cape in late October, because pretty much any wind direction is going to be off the ocean, and very difficult to get any snowfall down that way. And now this was the probability of 2 inches or more of snow. And you'll see again across central Massachusetts, better than a 50-50 shot of receiving more than 2 inches of snow. And you'll also see that indicated in the Berkshires. And notice again, obviously the probabilities are lower, but you do see, Boston at 24%. So that's definitely indicating, a 1 in 4 shot there. And this is something you're always going to see if it's an early season event or a late season event, unless it's an extreme situation like the Snowtober event we had back in 2011. That was really unusual, where there was high confidence in a damaging wet snowfall across the region. Most of the cases you're going to see the high terrain favored with temperatures around freezing, but that doesn't mean that you can't get snow in the lower elevations too. And this was our final snowfall forecast. This was the would be the midnight shift issued early Friday morning, and you can see the forecasters continue to trend upward. And actually, this was a fairly good forecast. Still a little light, but obviously we've got 3 to 4 inches right in central Massachusetts, a couple 2 to 3 inches in Foxborough, accumulating snow right down to the coast. So again, that's quite unusual. And then you see higher amounts indicated again in the Berks. So high terrain is usually going to be favored for a early season or late season storm, and this was no different. And with that, I'm going to turn it over to Rodney, who's going to talk about the model data that was used to forecast this event and some things we can learn from it.
Thank you so much, Hayden. That was a great overview of what we of our messaging and our forecast. But now let's take a look at some of the model guidance that we use to derive the forecast. So some of you winter weather fans may have heard of the 70-degree west, 40-degree north benchmark that we like to use here at the Boston office. And for those of you who are not familiar with that benchmark significance, the benchmark is used to determine if the probability of the I-95 corridor, in this case the Providence to Boston corridor, whether this corridor can get accumulating snow in the winter. And if the models suggest that the low pressure is going to track in the vicinity of this benchmark, our confidence of accumulating snowfall is higher. So in this case, you're looking at the European model ensemble. Again, a lot of the winter weather fans that we like to look at what we call deterministic guidance, and sometimes that's just one solution of the model. And as forecasters, we build our confidence by looking at whether the different members of the model agree with each other. So in this case, the ensemble forecast has the advantage of showing the solutions of different members. And if the solutions converge with each other, then we have more confidence. So in this case, the ensemble members show a clustering of the low pressure positions right around the 70-degree west, 40-degree north benchmark. And here you're looking at 3 days out. And to have such consistency and such clustering, that's a strong signal that we have a pretty good chance of seeing accumulating snowfall even for late October in southern New England. And so this is the 250 millibar jet streak forecast. and this is from the GFS. So the reason why we show you this is because it's, even though it is an approximate, depiction of how the jet streak looks like at 250 millibars, which is about 30,000 feet above sea level. We try to look for the trends and whether the models agree with each other. In this case, the signal is pretty strong that there's going to be an anomalously strong jet streak, which is, a small section of the jet stream. And you see the blue shading, that's 180 knots. That's howling at 30,000 feet. And so, when we see we have, this upper level trough, rotating across New England, and this trough going negatively tilted, and then you have the 180 knot jet, that is a strong signal that there's going to be very strong jet dynamics at play, and further increasing our confidence of a more impactful event. So this is the HREF model, and we like to use the HREF, which is the high-res ensemble forecast, and it is really an ensemble of 10 members. And so this is really skillful. We have learned within 36 to 48 hours. And this parameter, this is the 1 hour snowfall ensemble mean forecast. And the gray shading, that's you're talking about up to half an inch of snow per hour. The blue shading, that's up to 1 inch per hour. And as Hayden mentioned earlier, the temperatures are going to be very marginal for this setup. So if you're going to accumulate snow, you need heavier snowfall rate to overcome the initially warm ground temperature. And if the snow comes out hard enough, it doesn't matter if you're at 32, 33 degrees at the surface, you can accumulate not only on grassy surfaces, but also lead to slick and slushy roadways, even in the daytime. So, and this is, looking at about 24 hours out. And so seeing the ensemble forecast showing up to 1 inch per hour snowfall rate, again, this increases our confidence of a more impactful event. And this is the precipitation type depiction from the HREF, and the blue shading, that's snow, and green shading, that's rain, and the darker shading, that's depicting heavier precipitation. So you can see a swath of moderate to heavier snowfall, potentially over the I-95 corridor from Providence to Boston, and that, and as Hayden talked about how we decided to go with a winter weather advisory, that's actually one of the reasons, because the heavier snowfall rate could coincide with the tail end of rush hour, and it being the first snowfall event of the season, we want people to be alert of possibly hazardous roadways. And the other thing I want to point out is that you can see the rain snow line is right over, just south of Boston, between Bristol and Plymouth County, and as later on we will talk about, that's the approximate location of the coastal front. So east of the coastal front you get rain, and then west of the coastal front you get snow. And this is again the ensemble hourly snowfall rate forecast, and you can see again the darker shading. Don't focus on exactly where the darkest shadings are, but you can see the potential for half an inch to 1 inch of per hour snowfall rate over a good part of the region. And this is the probability of hourly snowfall rate exceeding 1 inch per hour, and you can see there are some pixels, 30 to 40%. So that's nothing to sniff at. That's a pretty good signal for moderate to heavy snowfall rate. And this is the 12-hour snowfall probability. So that's total snowfall over 12 hours, and you can see a good part of the area, including Boston, in the 2 to 4 inches zone. And this is expanding the goalpost to 24 hours, and you can start seeing 4 to 6 inches totals with, over 6 inches just to our west and north. And this is, and remember what I told you that the HREF is comprised of 10 members, and this is showing most of the members, and actually there are 5 members, but then there are 2 time steps. So the reason why we have 2 time steps for the HREF is because some of you may have heard of the windshield wiper effect. The models trend one direction and then it trend a totally different direction 12 hours later. So by incorporating the different time steps, you minimize the windshield wiper effect that we try to minimize when we forecast the weather. And now let's take a look at the NBM, the National Blend of Models, and that's actually what you're going to hear this, moving forward in the next few years. That the National Weather Service has really emphasized the use of the NBM, and as forecasters of the National Weather Service, this is usually this is our starting point, and briefly speaking, the importance of NBM is such that there's so many offices across the country, and it is important we have some kind of consistency to collaborate with the different offices so that we can create a weather-ready nation. So, but I'm just going to leave it at that for now. And this is the 90th percentile of the NBM forecast. The previous slide, that was the 50th percentile or the mean forecast. So in this case, the 90th percentile is showing a large swath of 4 to 6 inches of snowfall. And this is actually very close to what actually panned out. And so the reason, one of the reasons for why the actual snowfall was so close to the 90th percentile, which is the higher end forecast, was because of the anomalously cold low level cold air at 925 millibar, which is about 3,000 feet above sea level. So here, this is the depiction of the NEM-NES model, and you can see the green shadings. That's you're talking about -3 to -6 Celsius at 925 millibars. That's approximately, you're talking about the upper teens to mid 20s in Fahrenheit. And when you start seeing such temperatures, that basically translates to sub-freezing or near freezing temperatures at the surface. And because of this, even though it is an early season event with such a cold, dry air mass, this is almost like a midwinter type event where the snow is, instead of it being heavy and wet, it's actually dry and powdery. And dry, powdery snow accumulates more efficiently, so that led to the higher snowfall totals across the region. Okay, so in this case, notice the temperature dropping to between -4 to -5 Celsius along the I-95 corridor. Again, that's and thanks to that that low-level dry air, our fears of heavy wet snow did not materialize, except for a very localized area near the coastal front where the temperatures were more marginal and the snow was a little bit more wet and heavy. That led to localized power outages. But in a good way, we dodged a major bullet because because the dry, powdery snow minimized the power outages across the region. And this is the NBM forecast for the liquid precipitation forecast. You can see the higher liquid forecast is more towards eastern Massachusetts and the South Coast. And of course, when you get to the Cape, that mostly fell as rain instead of snow. So you can see why the I-95 corridor became the sweet spot, because you have the higher liquid QPF amounts, and also you have the colder air enough for snow. And you can see this is the observed precipitation thanks to the network of our observers and our automated sites. That you can see that actually the NBM liquid QPF forecast is very accurate. So one thing as a forecaster, I can tell you that for those of you who like snow, snowfall, there's a very simple formula that we use. Snowfall is equal to snow to liquid ratio multiplied by the QPF. So in this case, the QPF forecast was accurate, but because the assumption was heavy wet snow, so the typical snow to liquid ratio is 10:1. So in a heavy wet snow event, the ratio can be as low as 6:1 or 8:1. But in this case, given that it is dry powdery snow, it is actually as high as 13:1. So you multiply by that by the QPF, that gives you a large swath of 4 to 6 inches of snow across the region. Now I'm going to turn it over to my colleague to talk about mesoanalysis.
All right, thanks, Rodney. Joe is back. I'll do the mesoanalysis. So first of all, what is mesoanalysis? It just means an analysis on a smaller scale. So think global being the entire Earth. What we call the synoptic scale might be all of North America or the United States. And then mesoanalysis is more regional. So think New England or the Northeast. So we're looking at a smaller scale analysis during the storm. So to start, let's take a look at our surface map. And this was valid late in the morning on Friday, October 30th. And the one thing you could notice, I've got the temperatures here plotted in black. So you can see it's 29 in Worcester, 30 in Smithfield, Rhode Island, 34 Boston, and 39 down in Plymouth. Well, there's some sort of front going on here because you've got to jump from the low to mid 30s to the upper 30s and low 40s to the east. So where this red line is drawn in, this is actually the coastal front. So you have 34 in Boston. Actually, it should be 31 with a north-northwest wind. And then to the south, Marshfield and Plymouth both at 39 degrees with a northeast wind. So it's coming off that milder ocean that Hayden talked about. But with this coastal front there, the cold air is draining southward. So it's down to 29 in Worcester, 33 in Norwood, 34 in Taunton. So this cold air is coming down and causing the rain to change over to snow. And some of the stations were reporting heavy snow during this time. So now let's take a look at the jet stream. Rodney kind of touched on this a little bit. This was actually the analysis at 8 in the morning. And it might be a little hard to see the map, but Boston is right about here. So we've got the strongest winds here over southeast New England and the strongest wind speeds moving up the coast. So most of southern New England is in a favorable portion of this jet streak to help enhance lift and cause heavier precipitation. So as it turns out, this area also correlates pretty much nicely to where the heaviest snow was falling during this time. So it was that really strong upper level jet streak that helped enhance the heavier snowfall rates across our region. It provides an added source of lift. Then we come down a little bit in the atmosphere, and this is a map looking closer to about 10,000 feet above ground. We call the mid-levels. And you can see in this case, we've got the green, which is moisture. We've got plenty of moisture. But also there's some convergence here, so it might be hard to see, but we've got winds out of the northwest coming down across northern New England and more out of the southwest across Connecticut, Rhode Island, and Massachusetts. So these winds are converging. They're running into one another, and where you have convergence, that is another source of lift. Think of it as almost like a front. So that helped to produce a band of heavy snow up in northern Massachusetts. And you can see there are actually two bands on this radar image. This is the mid-level band up here, north of Springfield and almost into Manchester. And then our lower level band, that's associated with the coastal front to the south. And you're seeing a lot of yellows in this area because there's some mixed precipitation going on. But with most of our winter storms, you'll see two bands of heavy snow for the most part. One associated at low levels with the coastal front, the other much farther inland, which is associated with this mid-level convergence. So we call this our mid-level heavy snow band and our low-level snow band there. So as I mentioned, we had some mixed precipitation going on, and you'll see this a lot in winter storms. This yellow, it's not necessarily heavy rain or heavy snow. It's called bright banding, and it's actually the radar detecting ice and reflecting it back to the radar. So it's very reflective. Think of it as almost like hail in a thunderstorm. So this is where rain is changing to snow right near the coast. And I have overlaid, you might be able to see some of the what are called their MPing reports. So you can report those. You can download the app. It's just MPing, and obviously the green is rain, and these other, I guess they're kind of pinkish. That's almost snow. So you're seeing rain changing to snow as you head south. And then one other radar image we look at is called correlation coefficient. You may be familiar with this if you have radar on your phone. Typically, we look at these higher values of CC, which means we have uniform drops. So it's either all rain or all snow. And you can see up here to the north, this is all snow. And further to the south, it's pretty much all rain. In the middle, where we had that bright banding, you see these lower values. And that's where we have rain and snowflakes mixed together. So it really shows a nice transition zone going from rain to mix over to snow. So that's something you can keep an eye on with winter storms this year. So with that, I will pass it on to Frank Nocera, who's going to wrap it up and take a look at what happened.
All right. Thank you, Joe. The next slide here, we'll take a look at what actually fell, the observed snow totals here. And pretty impressive. If you remember, earlier in the presentation, our last snowfall forecast was generally for 1 to 4 inches of snow. And you could see here it was pretty much a widespread 3 to 6 inches of snow, anywhere from northeast Connecticut into the Worcester Hills area, northern Rhode Island, and into most of eastern Massachusetts. And that includes downtown Boston, the greater Boston area, which actually set an all-time record for the most snowfall on any given day in the month of October. The airport measured 4.3 inches. The old record was 1.1, so really smashed that record. And you can see some of those yellows there. That's upwards of 7 inches of snow in the greater Worcester area, and then also south of Boston. I believe the two highest totals I saw was East Grafton, or the Grafton area, is about 7.6 inches, and then East Braintree, just south of Boston, at 7.5 inches. So one of the interesting aspects of this snowstorm was we had just as much snow south of Boston at sea level versus the Worcester Hills, where Grafton is up around 400 or 500 feet. So it's pretty rare for that to happen, although it does happen. And as Hayden, Rodney, and Joe had mentioned during the presentations, the two ingredients to get just as much snow down at the coastal plain at sea level versus the higher terrain. We had heavy precipitation, melting snow for the first hour or two on the front end of this. So melting snow, you're taking warmth out of the ground to melt those snowflakes, cooling the ground. And then also we had those cold temperatures that Rodney and Hayden talked about as that tropical system pulled away Zeta. On the backside of Zeta, that advected or transported colder air into the system. So the combination of those colder temperatures and the heavy precipitation, that's the reason why we had just as much snow in and around the Boston area as the Worcester Hills. And it shows up here on satellite. You could see how the topography here, the white areas, snow. You could see as you get down into southern Rhode Island, there was very little of any snow. And then also as you get down towards the Cape Cod Canal, very little snow at all. And that's really where the coastal front set up, was down there in southeast Massachusetts. Now, just something I wanted to point out, you could see that the color, there's not much change from the Boston area to the Worcester area. But if you go farther west, if you go into New York State, you could see elevation did play a role there. The lower Hudson Valley, you could see the Hudson River there. That stands out. Very little, if any, snow in the Hudson River Valley. However, to the west in the Catskill Mountains, they show up nicely there, as Joe's pointing out. Plenty of snow in the Catskills, and then also to the east in the Berkshire. So In New York State, elevation did play a factor. They had less cold air than we did, and they didn't have the heavy precipitation that we did. So elevation can play a role early in the season, late in the season, even during the middle of winter. But when you have that heavy precipitation and you have enough cold air available, it could snow just as heavy right down to the coastline as it can in the higher terrain. Okay, the map to the left here is power outages across the state of Massachusetts during the event. And then to the right is the surface map for 1437Z. So that's roughly 10:30, given we were still in daylight time. And you could see the power outage map there to the left, any shaded green, that's about 10% of the county or that town may be without power. I believe the yellows are like up to 25%, and then the reds are really high. I believe it's like 75% or greater. So you can see there's a little bit of a bullseye there south of Boston, those higher power outages there, and that's because that was very close to the coastal front. So as you get closer to the coastal front, you can see on the weather map to the right, Marshfield is reporting a temperature of 39 and Plymouth 39 as well. So as you get closer to that coastal front, warmer temperatures, you have a mix of rain or snow, and if you do have snow, it's very wet and heavy, and that's why we had a little spike there or a maximum of power outages just south of Boston. And as Rodney and Hayden talked about, and even Joe earlier, we were fortunate that temperatures, it did snow 29 degrees at Worcester, 30 degrees in northern Rhode Island. If it was warmer, those power outages would have been much more widespread. So we kind of dodged the bullet here. We did have power outages, but it could have been much worse if it wasn't as cold. So kind of a blessing in disguise there. And here's an animation of the cold temperatures at the surface. These are observed surface temperatures. The loop begins at about 2 a.m. in the morning and ends about 6 p.m. that evening. And you can see how the cold air, temperatures falling into the upper 20s and lower 30s, just surges from north to south across northern Massachusetts into Connecticut and Rhode Island. But you could also see there in southeast Massachusetts that coastal front is very stubborn, and it's hard to get the temperatures down until later in the day when the precipitation ends. And due to this cold air coming in a little bit sooner, the rain changed over to snow about an hour or two earlier, so that led to some higher totals. That was one of the components why we had snow totals higher than what we had anticipated. Here's a Google traffic map, which we're all too familiar with. This was right in the middle of the event. I believe this was probably around 10 or 11 in the morning. You can see definitely impacting the commute. As we all know, oranges and reds mean very slow traffic. And the main roads, yeah, they were just a slushy accumulation, but secondary roads were snow covered. And even more importantly, on some of those weather maps we were showing you, the visibility was down to a half mile or less. So the visibility even contributed here to the traffic. All right, let's take a look at some pictures around the area. And here's North Adams in Berkshire County. Pretty high elevation here in North Adams, but you can see here roads, slushy accumulation here in North Adams. And then the image here to the left, this where we have this tractor trailer off the road. This is in Canton, Mass. So this is, just outside of Boston, Metro West, and this is 95 in Canton. So pretty major road there, and obviously impacting travel. And then the image here to the right is Massachusetts Emergency Management Headquarters in Framingham. So definitely enough snow there to break out the plows. And a picture from Westboro from Hayden Frank, snow-covered roads here. And also in Central Mass, you can see some pretty impressive accumulations here. And more in Medway. And yeah, and then this is a picture of my backyard. The point here is just how heavy and wet the snow was on these evergreens, really weighing down the branches, and especially way in the back there, you can see the branches almost touching the ground. So even though Cumberland, Rhode Island is, quite a distance, good distance from the coastal front, still the snow was heavy and wet enough to bring down some branches there. And another picture here from Westboro, showing you how wet and clingy the snow was even there. And then, yeah, we had some some breaks of sunshine late in the day just before sunset. So really set the scene for some almost like postcard type pictures. and this was in the south end of Boston. Grafton, Mass. Again, that was I think the jackpot, about 7.6 inches of snow in Grafton, and their elevation is about 400 or 500 feet. And even though Grafton was well removed from that coastal front, you can see a large tree limb down on power lines there, and the image to the right is in Cumberland, Rhode Island, where a large branch was partially blocking one of the roads. And then Holbrook, very close to the coastal front, and where we saw in that power outage map where some of those reds were painted in, that's in and around the Holbrook area. You can see a very large tree down in that area, and they were hit really hard with power outages there. And Scituate, Rhode Island, more of the same, heavy wet snow. And I assume this is from a drone in Topsfield. Real nice image here showing you good snow cumes across this area. And another nice image just before sunset here in Saugus, Mass. Really another postcard picture. And again, thanks to Ronnie for capturing this just outside the office in Norton, Mass. So that's all I have, and I guess we could take questions now.
Yep. Okay, thanks, Frank, and Hayden and Rodney. And Rodney, thanks for the picture. You had to go run out in the middle of the snow and avoid other duties because it was snowing, and we know you get excited. That's okay. All right. So I'll go to the questions, and Rodney, Hayden, and Frank, you can help me answer them. Just a comment first from Ronald. I think I saw more snow in that October storm than we had all winter last year. Probably pretty close to it in some places. Didn't have very much. It was definitely a mild winter. Question from John. Which model most correctly predicted this system? Any Hayden or Frank, you guys, or Rodney, you guys worked up to this event, I think. Do you remember?
Yeah, I could
Okay.
I could comment on that. Yeah, I would say, the HREF did a really, really good job. I mean, none of the models really, forecasted 6-7 inches of snow. But I think the HREF did a really good job there showing you the rain snow line. It was pretty much spot on where the transition was, and even the hourly snow rates, it did pretty good. And obviously, just like all the other guidance, it ramped up and got more bullish as we got closer to the event. But Rodney and Hayden, feel free to chime in on your thoughts.
Yeah, Frank, I agree. I think what really pushed a lot of people over the edge from going beyond the 1 to 4 inches was one of our short range models. Some of you may be familiar with it. It's called the HRRR model, and it really picked up on kind of a tail end of the storm during the mid-afternoon hours, rotating through central and eastern Massachusetts. In Westboro, that's definitely where we had our heaviest snow during the early afternoon. And I think that took a lot of places from, say, 2, 3, 4 inches to, 4, 5, 6 inches in kind of a short window. And some of the other guides didn't really pick up on that, had it ending a bit earlier. But the HRR kind of wrapped things in around the departing tropical system well to our south, allowing that cold air and heavy precipitation in the form of snow to occur.
Okay. Thanks, guys. Let's see. Comment here from Joe. He's a forecaster, and when he was on a conference call, we didn't think Logan and other areas on the coast would have several inches of accumulation, giving ocean temps and the time of year. The storm taught us a lot and had a hard time buying into the models with the higher end totals. I don't think you're alone on that, Joe. So, as we mentioned, these early and late season events are always the most challenging as far as accumulations, especially during the daytime. So, yeah, it's, we always go back and learn from, when the forecasts aren't exactly right, and, the forecasts were a little bit low in this case. So, we use this as a case study for future training. So, and I think
that's a good point that Joe brought up there in that question. Mm-hmm. And one of the things that I'll add is wind direction. And going back to what Frank kind of showed on the wind direction, if you looked at Logan, the winds are like 340, 350 degrees. So almost a little west of due north. So in a way, it's kind of like the ocean isn't impacting that, because the wind, if you look at the northwest wind, is coming straight down from New Hampshire. So And that's why you see that difference on the coastal front where the wind was northeast. Temperatures were in the upper 30s and it was raining. But where that wind was north-northwest, you're getting a straight land trajectory. So even though you're on the ocean, the wind's coming from the land. That's something to really keep in mind, even as we get, into December and January, because obviously that still has an impact on the rain-snow line.
Right. Good point, Hayden. Yep. Okay, from Ronald, was there a high-pressure system situated to our north in this storm?
Yes, this is Rodney. And that's actually to go off on Hayden's point that, because the wind direction is, because there's a high pressure to our north, it allowed the low-level cold, dry air to seep south into southern New England. So pretty much, unless you are living right by the eastern Massachusetts coast or on the Cape, the temperature was actually below freezing, and that allowed for the cold, the dry, powdery snow to fall. And just another quick point. So in this case, I think the global models had a hard time with this system because they don't have the mesoscale details of the wind direction, and so in this case, I would say, in response to an earlier question, the mesoscale models like the NAM-NAS, the HRF, they did better because they were able to identify, map out the surface analysis better, and therefore were able to handle the precip types and temperature better.
Okay, thanks, Rodney. Next one I'm going to pass to Frank because he talked about this a little bit. From John, how did the rain prior to the arrival of snow impact snow sticking on the ground?
You want to just repeat that one more time, Joe?
Sure. How did the rain prior to the arrival of snow impact snow sticking on the ground?
Well, yeah, it's a good question. I don't think the rain really had a lot to do with it. I think it's once the rain changed over to snow and then the snow was melting, it wasn't sticking. Whenever you have snow melting, you have to take the heat from the ground to melt those snowflakes. So melting is a cooling process. So the more melting that you have occur, you're cooling the ground more rapidly. And that's how we got those ground temperatures down. We didn't show it, but we have images showing that the ground temperature, the 2-inch soil temperature, just a few days before this event was in the upper 40s to lower 50s. But the combination of cold air getting drained southward into the system that morning, plus the heavy precipitation rates leading to the melting and the cooling of the ground, it's amazing how much cooling took place, and we actually got the ground close to freezing. So it was really more the melting snow the first few hours of the event that was able to get that ground temperature down. Again, melting snow, you got to take heat from the ground to melt those snowflakes. So melting is a cooling process, hence that's how we lowered the ground temperature.
Great. Okay, thanks, Frank. Let's see, I'll pass this one to Hayden from Ronald. When Zeta moved out to sea to our south, did it strengthen over the Gulf Stream?
Well, the intensity, it became, as they refer to it as post-tropical, where it takes on what we call synoptic characteristics, something we see in our winter storms. It basically maintained its strength. The one thing I'll say that's important here, because our snowfall totals, we had the idea, but we were obviously on the lower end of what happened, a little too conservative. But it's also important to keep in mind, one thing that leading up to this event that was uncertain was, would there be too much dry air coming down from the north that would erode the northern edge of the precipitation? And actually, if you get into New Hampshire, I mean, there was snowfall, but it was generally on the order of a couple inches, and then decreased as you head further north. So there was kind of a fine line. You had to be where you had the precipitation heavy enough to accumulate and where it was cold enough to be snow. And, if you got too far north, your accumulations diminish because you're away from the heavier precipitation, obviously too close to the system, too warm, especially the Cape with the north wind coming off the ocean. So it was a kind of a fine line, but the system basically maintained its intensity, but it was more of a matter of how far north and west that heavy precipitation would get to allow for snow accumulations. One final point I'll add, out in the plains, the Midwest, Denver had a storm in September where they were close to 90, and then I think they were in the low 90s, and then they got several inches of snow the next day. So it's all about snowfall rates. If it's heavy snow, what happened, if it was really warm the next day, or if it's out of season in October or April, it's going to accumulate. Where it makes a big difference is where you have light to moderate snow that can have real trouble accumulating with, warm ground temperatures or higher sun angles that you deal with.
Okay, thanks, Hayden. And I see a question from John almost talking about the same thing. He said, snow melted on paved surfaces in Springfield. Was that due to paved surface temperatures above 32, infrared radiation coming through clouds, or both? And it was kind of with that, but also the lighter snowfall rates make it tough to accumulate on the paved surfaces during the daytime. So if you get those higher snowfall rates, then you can overcome that pretty easily. Let's see. Comment from David. Tuesday precip forecast for Bradley was only slightly more than the actual 2.08 inches. That's correct. It was those darn snow to liquid ratios that kind of got in the way of the snowfall forecast. But as we mentioned, the liquid precipitation was pretty much on the mark. So, it was just that timing of the arrival of the cold air and the snow to liquid ratio were the reason for the forecast being just a little bit too low. From Ronald, what contributed to the 10,000 power outages if the snow was not wet and heavy? Leaves on trees or wind?
Leaves on trees were a big factor. And as Frank pointed out, where most of the power outages were south of Boston on that coastal front, where temperatures were right around freezing and the snow was, wet in a small area. A lot of times you see those scenarios where there's a very localized area that receives significant power outages. That happened in the blizzard of 2013 in a small area across Plymouth County, right on that coastal front. So that coastal front is where you're really subject to wet snow and potential power outages, especially with leaves still on the trees.
Okay. Another one from Ronald. Why was there no sleet or freezing rain with this early storm? That's a good question.
Ronald, this is Rodney. The reason why there was no mixed precip with this storm is because of the very cold, low-level dry air, and typically you get freezing rain or sleet when there's what we call a layer of warm air aloft, and depending on the depth of the warm air, you can get if it is less warm air aloft, you get sleet. If it is more warm air aloft, you can get freezing rain, especially if the surface is below freezing. But in this case, the entire atmospheric column is below freezing, and so the snow has no issue making it all the way to the ground. The only area that saw maybe a brief wintry mix was really towards the eastern Massachusetts coast, especially towards Plymouth County, where the coastal front was. The temperatures there were more marginal. So, but otherwise, along and west of the I-95 corridor, it was pretty much rain changing over to snow almost immediately.
All right. Thanks, Rodney. I'm going to send this next one to Hayden. It's one of our historical questions. So from John, and we've heard this a lot, how did this event compare to the October 2011 snowstorm, Snowtober?
Yeah, great question. Well, for most of southern New England, Snowtober was a much more significant storm. When we had people without power for weeks, it was really a very destructive storm. In that event, we had places, basically western central Massachusetts into Connecticut, that received 12 to 18 inches, even some places in the Berks over 2 feet of snow, which is historic. It was a historic event. The amount of wet snow on where there were still, leaves on the trees, just resulted in tremendous tree damage and power outages. So this event didn't hold a candle to that, to be honest. The one exception to that, in terms of put it in context, in the Snowtober event, the Boston to Providence corridor basically received, a coating to 2 inches of snow. There wasn't, you had to be, 15, 20 miles northwest to really get into significant snowfall from the Snowtober event. So along the immediate eastern Massachusetts coast, this was historic in terms of amounts, because you just don't get it. Boston, 4.3 inches, the most the city's ever seen in October is 1.1 inches. So that was the, where it kind of, in terms of where it lays out historically and memorable. But obviously, in terms of impacts, I mean, it was nothing compared to Snowtober.
Okay, thanks, Aidan. Just let's see a couple more. We have a comment and then just one more question. So from Anne Marie, she measured 3.5 inches of snow 25 miles northwest of Boston, and says she has around 40 years of records, and this is the first time we hit snow before the first frost. She's at elevation around 300 feet, which often protects against early frost, which she sees down around 100 feet in the river valley not far east. So interesting. Yeah, a lot of places did have snow before the first frost. I think because we were still issuing our frost advisories at that point, and then I think we just gave up after this one, guys, once the snow hit the ground. All right, and our last question from Jonathan, and I'm going to give this one to Hayden too, because he's our weather records guy. Interesting note, last measurable snowfall in May, and then in October, barely 6 snow-free months. Is it unusual?
Yeah, that is extremely unusual. Probably one of the smallest time periods without, with measurable snowfall, in that we had, places had it in early May. Obviously not a lot, but places had a very small amounts, and then this at the end of October. So usually, you're dealing with a much larger time frame in between any accumulating snow. But that, was an interesting fact about both of those events.